I can say any neural network, as in even the state-of-art neural networks, they will have something known as input layer. First of all, is the screen visible properly? If it's not, you can just paste it. Yeah.
Yes.
Yes, it's
Okay.
visible.
Okay. So let's start with basics. So we have one layer and we would have some hidden layers. We could say n number of hidden layers, and then we could have output layer also. So I can just name it this hidden. This portion, sorry, this is the input. This portion is the hidden part, and this is the output part. I hope this is clear. I'm just repeating myself because there might be few people who are not from computer science domain, so they should know all this before even starting it. And we have already covered it, so I will only cover the basic part. Now this we saw. So whatever part we are drawing here, it is nothing but it's a connection of nodes. Or as we saw yesterday, it could be units too. So it could be nodes or units, whatever you say, and it could be connected in any fashion. So maybe this, not like this, just a second. Yeah. So it could be connected in any fashion. So maybe like this, few connections are like this. It can be anything. It could be fully connected or maybe some other connection based on our training, based on our weights. That's fine. Now, what is present inside this node? I was drawing it yesterday, but let's see it again if it wasn't clear because we did cover it very quickly. So I can say the one node. So what I can say, this node here. So I'm just representing this node over here. So this node here, what is there inside a node? This should be very clear. Only when you actually think about from a node perspective, then you can get to know the in-depth thing what your layer is doing. If you just think about a layer, if you just think about multiple layers or the entire model, then if something goes wrong, you won't be able to figure out that what part is missing or what part is done incorrectly. Okay. So we have something, we have two values. So we can say Z and we can say activation. I just explained this due to time constraint yesterday, but just let's see what is it. Now, if I say Z could be calculated based on, we have the weights. So I'm just denoting weights by this. Weights are all the weights associated to any connection. Okay. So these are the weights that we train our model for. In the end, what we want these weights to get optimized. What I mean by optimized weights, that also we will talk about. So these are the weights that we are finding. Okay. Now in the representation, we always say weight transpose. It's just a transpose operation on weight matrix or maybe a vector, and we have x and this. So this is the equation for z. So whenever you are calculating the z part of it, you can visualize or you can think in your mind that this is what you are doing. Okay. Then what about the activation? So activation part, you can say any function. Now this function, we will be talking about any function. So whatever z we actually got, we will be passing that z to a function. What kind of function? There are multiple functions. We will be talking about it. So we will be passing it in a function, and whatever output it gets, this is the output. And this is the output that will be passed to the next connection. So when I say a node is there and it passes something to the next node, what is getting passed over here? This A is getting passed. And how is it getting processed? Using this function, and this is the equation for that. Is this clear? This is very basic. You can actually go and read about it, but we should be reading it before the session so that we are on the same page while building the model. Okay. One more thing that we saw. Okay, let's talk about ReLU. Okay. Yesterday we saw an activation function ReLU, and we were using ReLU. Why we were using ReLU? We will see. So mathematically, if you see visualizing it ReLU, so if this is your plane, ReLU is a function that is like this. I'm just denoting because if I mark it over this, that's 0. So ReLU is something like this. Okay. What does this mean? This means that any value, this means that any value on the negative part will be given as 0. This is clear. Anything on the positive part, so any value on the positive part will stay as it is. It will be outputted this value. Okay. This is clear. Now, if this is clear, it's very easy to write a simple formula for ReLU, that is max of 0, comma z. Mathematically, you can represent it like this. What does this mean? This means that whenever a value of maybe a -1 is passed, it will say max of 0 or -1. So it will automatically output 0. Okay, that means for anything negative, it will output 0. On anything positive, it will output the positive value. Is this clear? Okay. Just I'm assuming that everything is clear. Let's go and check one more topic. Okay. So we will be seeing something. Okay. So one thing that I was drawing yesterday was something like this. Okay. I don't know, was it clear properly or not that what this representation mean? So we will be seeing that representation now. Let's assume we have two variables to optimize, or we have two variables. Okay. So what do I mean by a variable? Let's suppose if I am thinking of it as a plane and we have two variables. So let's assume we have one variable that is x1 and one variable that is x2. Okay. So now we have two variables and one is x1, one is x2. That is fine. Now x1 and x2 are not properly scaled. What do I mean by that? Let's assume I will give you a real world scenario. Now you have a database. Okay. I will always talk about in database perspective so that it's very clear and it's very intuitive. So yeah, first of all, these are the columns. This is fine. These are the rows. This is fine. And whenever I say we are talking about a tuple I mean by the entire row. This is a tuple. Okay. So whenever in this entire session, if I am talking about a tuple, this is the row I'm talking about. Okay. Then we do generally have if it's a supervised learning algo, we will have label. You can say now label, it's one column in the end. Yeah, that's label. Now we had label one column yesterday, but we had to encode it into a bigger form that that we will also discuss again. So now it's x1 and x2. And suppose the columns are two. So if I'm talking about x1 and x2, let's see what the database would look like. It would be just x1, x2, and maybe your y label, and this is your tuple. Just an example. And if these are not scaled, if I say that x1 value is very big, so if let's suppose it's a database of people driving different vehicles, okay. Now there is one attribute or maybe one column which is saying age of the vehicle, okay, how old is the vehicle, and there is one column which is saying miles driven. So I'm just writing miles, or you can just say kilometers if you are very comfortable with that, driven. So how much the vehicle was driven and what's the age or maybe how old is the vehicle. Now this age would definitely vary maybe from 0 to 20. I'm just giving one example. You might say that I'm using my vehicle for maybe 30 years. That's fine. So we will have that kind of scale. But miles would definitely have a very large scale. I will just represent this as this very large scale. Okay. If we are comparing age and miles together, our model might feel. That is why it's always a better practice to think about in terms of a node and going in depth. So our model might feel that this attribute is more important because the values are higher. This is not we want to convey it to our model. This is one problem. And the other problem is if it's not scaled properly, then what might happen if suppose this is scaled from this place to this place, value of x2, and x1 is scaled from this place to this place. So you can just visualize or you can just see that this scaling, this is more than this part. Okay, the black line is greater than blue line. Okay, and this is what I was drawing yesterday. This is the figure that we are actually drawing. Okay. And then we are starting at one point. So whenever I was saying that we are starting from this point and we want to reach to this point, what does it mean? It means that we want to reach at this point. This point as in we want a value of x2 at this particular point. This is the most optimized point. And we want the value of x1 at this particular point. This is the most optimized point. And to reach this place, we will start some at some arbitrary place because we won't know what is the most optimal value point. Okay, that's why we will be starting from some arbitrary point, and from that arbitrary point, we will try to reach our target location. Is this clear? Okay. So now if that is clear, what I was doing yesterday, that I was saying that we might go here and then we might not converge or maybe later on converge. So that might happen because if we are starting from this point, now this is not scaled, so I might go somewhere else too, and it might take a longer time. So what we are doing after scaling, so if it gets scaled, let's draw a scaled representation now. Okay, so let's see it again. We will have x1 over here, we will have x2 over here, and let's see that if we have scaled values, what will happen. So now if it's okay, the circle would be bigger. If it's scaled, so let's see. So now x1 and x2 values are in the same scale. You can actually think of it as normalization. Okay, so you're normalizing the value. After you have normalized the value, the representation might, yeah, I know that's not a circle. I'm just drawing a circle here. So representation might look like this. Now you would ask that, okay, what would we gain from this to this point? As soon as you scale your values, you now know that while traveling, if you're traveling from this point, then it is much easier for you to reach that point. Is this clear? This distance you have reduced. It's a very basic discussion. There are n number of attributes. It's a multi-dimensional plane. Just to simplify it, we are talking about 2D. Okay. Now in this, just by saying this, you know that it becomes very easy to reach to the target location. What our model is doing when we call fit, it is training. But okay, the model is training, but what it is doing internally, it is traveling from this point. We see different epochs. It is traveling from one location, from the starting location, and it is trying to reach at a point which gives us least loss and the greatest accuracy. That is the most optimal point. So if we reduce this, if we scale our values, then reaching the point becomes much easier. So that is why it is said that if you are using scaling properly, if you're scaling your inputs properly, then your training time gets reduced. That means you are expediting your training process. Okay, this is the reason that we do it. Yesterday, I couldn't get into so much depth because we had to cover two different models. Today, we will be covering one part of it. That's why we have time to discuss all this. Okay, so if this is clear, let's move further. Now, there was one thing. Okay, let's discuss Adam also here. Now, when you see this, okay, so this is a 2D representation. Let's suppose I tell you, think of it as 3D. There can be three variables, so think of it as 3D. Yeah, don't go with the circular rings. It will be proper, but I'm just depicting it with my diagram. Okay, so now let's suppose you start from here. Okay, it is not always that you would go in this horizontal direction. Okay, let's think of it as in terms of velocity. We are not deviating from the topic. Just to make it very simple, think of it as velocity or think of it as speed or something like that. So it's not that you will have only one direction. It may so happen that you might have this direction also. So it's not always that you will be going from this point to this point and just rotating in that one plane. It might be possible that you are going out of the plane. and then coming to this location. It is possible. So what Adam is doing, or what optimizers are doing, if you read about RMS prop and other things, what they are doing, they are trying to reduce this part. So I will just change my pen so that it's much clear. Yeah. So what they are doing, they are trying to reduce this velocity, or maybe the direction. They're trying to reduce that so that you only travel in this direction. Okay. So once this gets reduced, so you automatically, sorry, yeah. So you automatically travel in only straight direction. It's not exactly straight, but this is what an optimizer is doing. So if you think about an optimizer, what it is doing a lot of things in the background. Now this, I'm saying, it's maybe multi-dimensional plane. Now think about if you have 100 features. Think about if you have 200 features. If you have so many features and it's a multi-dimensional plane, this is what the optimizer is doing. It is trying to take you from the initial point to the most optimal point in the least time. Okay. I hope this is clear. While using Adam, I said, let's hope that everybody knows what learning rate means. I didn't have time that time, but let's see what a learning rate, what I mean by learning rate. Okay. So if we visualize this, just to visualize it, I will just draw it like this. Okay. Fine. Let's suppose that we want to reach this point. This is the most optimal point where our loss is minimum. Okay. So this is the point where we need to reach. Now, to reach this point, we can start at some arbitrary point over here. Okay. Now, at every epoch, I hope you guys know what epoch is, because yesterday we discussed it was training for one epoch, and then we were seeing the average, the validation loss and the validation accuracy. So after every epoch, we are seeing the loss. Okay. And so it jumps one step at every iteration. Okay. So if suppose I'm starting from here, I might jump here just to visualize it. I might jump here. So what does learning rate do? Learning rate actually, whenever you change the learning rate, this is what gets changed. That how far you're jumping in one go. If your learning rate is very high, then you would jump farther. Okay, and you might reach your most optimal point quickly. And if your learning rate is very slow or maybe normal, then you might take more jumps to reach your destination. Okay, then you would feel that why don't we keep the learning rate very high as possible? Let's go and jump it in one shot or maybe two shots. But this is not always possible. Why? Let's see why. So there might be a scenario because your learning rate is very high, that if you start from here, your learning rate is very high, you come at this point, you come at this point, because your learning rate is high, you jump out of your optimization. And if you have already trained few of the neural networks, and if it's not properly optimized, you might have seen in some scenarios that at certain point of time your loss was decreasing, and after that it was increasing. What is happening at that moment? This is what it's happening. So if you don't know how learning rate is affecting your model training, then you wouldn't know that what to actually optimize at that given situation. So that is why it's very important to know about these basics. So if your learning rate is very high, this case is also possible. So what should we have? We should have a learning rate, a high value of learning rate, because we want to reach the optimal state quickly. But we should have a lower value of learning rate so that we don't miss our optimal point. So there is something called learning decay. What it is doing, it is saying that initially I will jump farther, But as soon as I know that I have jumped a lot, after that I will jump for very, very small steps to reach a point. Okay. So this is what internally they are doing. You can go and read about it, but this is what is happening. Right? There was one more thing which I couldn't cover yesterday, so I will be covering today. That is dropout. So yesterday I said that let's use dropout, and I was assuming that everybody knew dropout, but let's just see it in just brief idea of dropout. Okay. So let's suppose we have, again, let's go back to the node story. We have different nodes. Okay. This would be connected via different ways. Let's suppose, yeah. And let's suppose it was connected via this and this. Okay. What dropout is doing while training the model, in between, if I use the dropout layer, it will automatically switch off few nodes in between. Okay. Which nodes it will automatically randomly pick. It will automatically switch off few nodes. What do I mean by switch off? I mean by switch off is whatever output they were sending before, it will automatically remove their output. So the intuition would be that that node is not present in that network for that specific training example, or for that specific training batch, or for that specific iteration. While training, it's not always. So maybe sometimes it will just remove, yeah, just a second, yeah. Sometimes it will remove this and this. Sometimes it will remove, if I give numbers. So sometimes it will say, okay, I will remove 1 and 2. In between training, it will say, I will remove 1 and 3. In between training, it will say, I will remove 2 and 4, and so on. So you got an idea. But now you would think that why are we even doing this? Just by doing this, you are making your model more robust. So even if the input changes, you are not worried about all the nodes in the network. So the other layer, which is not getting the input from this layer, if we have dropped, if we are using dropout and that particular instance is not giving, then the other layer might think, okay, this is not always the case that I will get input from these two nodes. I should also consider these two nodes and learn more, because there is a possibility that few nodes are giving you a higher output and you always take those nodes. But if something goes wrong in those nodes, then the network would suffer. That's why we use dropout. So it's just regularization. I hope you guys know what regularization is, but this gives an effect of regularization. This is what I wanted to cover before today's session. But if there is some other topic, then we could actually see it maybe post session. So we will start.
I want to ask question regarding learning rate.
Yeah, yeah,
Um, there are some default values for optimizer, right? For Adam
yeah,
point 001 like that,
yeah,
right?
yeah, yeah,
So it is not necessary for each and every data set the default value will work,
yeah,
right?
yeah.
So yeah, and what I want to ask that, is it okay that if we after experimentation we will keep the learning rate constant? For example, for my data set, the learning rate is suitable like a point 0001. So is it
Triple
okay?
zero one. Constant as in, I didn't get you. So if you're
Uh,
for the entire training phase, you are saying you
yeah,
will keep the learning rate constant.
yeah.
Okay,
Is
so
it okay?
see, keeping a learning rate constant or maybe variable, that totally depends on the kind of network you're training. If suppose your network is not big enough and what you are seeing that the network is getting trained in adequate time, then it's definitely fine to keep the learning rate constant. You vary the learning rate only when you feel, okay, my network is taking way too long to train. So let's increase the learning rate so that it trains and converges quickly. Only in that scenario, you would want to change your learning rate. And if you reduce your learning rate, then the training might go maybe for a longer period. So once you feel the training process or maybe the training time has increased drastically, then only think about changing your learning rate. If your model is not way too big, then it's fine to have a learning rate constant. That's fine.
And is it okay na ki if default value is 0.001 for Adam,
Yeah,
and
yeah,
if we are getting the good results for learning rate as 0.0001, so is it
yeah.
okay?
Yeah, it's definitely okay. See, the default value, what they are setting, it's an optimized value so that you don't jump way too long, you don't jump way too short. But for the data that you have and for the model that you have, you can use a very small learning rate as well so that you want to converge to the optimal point and you are not worried about the training time. For because if you are worried about the training time, only think about learning rate. But now for your model, if it's running in a proper way and you have no issues with the training time and you're just worried about the accuracy and you're getting the desired accuracy, it's fine to use any kind of learning rate. But there are few learning rates also. So in the initial phase, you can actually read few research papers. They have given certain values, but what they are saying, these certain values are values when you don't want to think about your learning rate. But if you have already thought about your learning rate and you're getting a desired accuracy, don't change that.
Okay, one more thing I want to ask that for experimentation we are using different nets, right? There are
Yeah,
several nets, dense
yeah,
net,
yeah,
Google net, all that.
yeah, yeah.
So for experimentation, I'm keeping all the hyperparameters as same, like
All the
learning
same. Okay.
rate, because
Yeah,
data set is similar. So for
yeah.
that data set, I want to check whether which network is good for my
That
work.
particular data set. Yeah, yeah.
Yeah, so
Mm.
I kept the learn means all the hyperparameters, learning rate, optimizer, and all rest other things. So,
Yeah.
but for some, for example, I have trained six net, different
Okay.
nets like dense
Okay.
net, mobile net, squeeze net, shuffle net, all that. But
Okay.
for five nets, I'm getting same results, somewhat
Yeah. Yeah.
0.5% or 1% or 1.5% here and there.
Difference. Yeah.
But
Yeah. Yeah.
only for a dense net, the network is not training properly. Like we are saying, the overfitting problem and all that. That
Yeah. Yeah. Yeah.
training accuracy is increasing and validation accuracy is stuck at that point. So I
Okay.
want what is the reason behind? Can you tell what is the reason behind that? That five networks are training properly, but only
Okay.
dense net is not giving the results for same hyperparameters for same data set. And everything is similar.
Yeah. So see, the thing is now it totally, that's what I was saying. It totally depends on the model that they have created. Now you are using a pre-built model. So the creators
Yeah.
of model must have created in a manner that they must be using so that they have some preset values. For this kind of architecture, some learning rate might not work. So what you need to go through is go through the entire paper or maybe wherever they are published and check, do they have some preset defaults or do they have some optimized values for it? If it's not there, you can actually check because many people must have implemented or used that in real case scenarios. Then you need to check because your learning rate will definitely depend on what kind of model
I'm
it is.
not talking about only learning rate. I'm talking
Other
about all the
hyperparameters also.
parameter. Yeah.
Yeah, so that all the hyperparameters are dependent on your model. So it's not that if you use any model, if one model is giving you a better result with those hyperparameters, the other model would also give you the same result. That might be a possibility that it might not give you the same kind of results and you need to optimize your hyperparameters.
But in this case, five are giving the almost same results. Five
Yeah,
models are giving
yeah,
almost same results, and one
yeah.
is not giving the same results. So, what is the reason
Uh,
behind that?
that we
But
can only know after we go through the model layer and checking that.
okay, and
Yeah,
we
yeah.
cannot say that in this case, na, ki, the data is overfitting, because for five models it is not overfitted, and only one model that training accuracy is increasing, but validation accuracy is now after some point it is at the same point like that.
Okay, you're saying validation is at the same point, training is increasing.
Yeah, we are saying that overfitting up data set is model is overfitting and
Yeah,
all
because
that.
just by these two parameters, anybody would say that the data is overfitting because you're
Yeah, but
training.
for
Yeah.
five models, the that thing is not there, na. Only for one model that thing is there. So can you say that the model is overfitting in this case?
We can definitely just if you are just giving these two values, then anybody would feel that it is overfitting. But to go in depth, we need to have the model in front of us, and only then we would know. But yeah, if you are saying your training accuracy is increasing and your validation accuracy is not, then it's obviously a case of overfitting, and we need to
But
check
for
if it's
other
yeah.
models, that is not the case, na. For five models, it is not the
Yeah.
case.
So other models, the architecture is different. So if the architecture is different, they must have it handled in a different manner. Also, maybe the regularization pattern in those models is such that it's not overfitting. But in this model, the kind of data that we are supplying, it might overfit. I'm not saying it is overfitting, it might overfit. So for these kind of scenarios, we need to go in depth of the model. We need to check what training parameters are and what layer outputs are. And based on that, we can check that which layer is giving us improper results. And based on that, we can fix that layer. So it's
Okay.
not very intuitive just by seeing accuracy, validation accuracy, and your training accuracy. Once that is there, then you can go layer by layer.
Okay. Okay.
Okay.
Thank you.
Yeah. Oh, yeah. And I guess you asked me a question yesterday regarding the proportion that you wanted.
Yeah.
The
Yeah.
Yeah, so I read about it. I don't think so. TensorFlow is directly supporting it, but what you are trying to achieve is that stratified collection. So you have different
Yes.
population. So in the test train split in sklearn library, there is
Mm.
a parameter. Have you seen the stratified parameter in the end? Stratify. You can
Yeah.
actually go and look that stratify. I guess that might help you because what stratify is doing, it is saying what is the population of different classes and it will pick based on the percentage of population. So it will go to different classes and it might give you the result that you want. So you can just go and check
Oh,
that.
okay. 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 Thank you.
Yeah.
I will check that.
Okay. Yeah. So let's continue. Yeah. So we have finished dropout part. So now, once we have finished the dropout part, let's go in the hands-on session. But before that, there's one thing that we discussed yesterday. That was our main goal. We should know what our main goal is, and then based on that, we will have the session. So yesterday we covered two things. We saw an MLP model. Okay, that is fine. Then we saw a CNN model. This is also fine. But let's suppose there are so many models pre-built, existing models, which different organizations have already trained. Let's suppose I want to use those models. Okay, you just pick those models, you just see their architecture, what kind of input they take, what kind of classes they have, and based on that, you can use those models. But let's suppose your use case is slightly different than their use case. They might be identifying 10 or 15 or 20 classes, but what you want is only maybe 5 classes or maybe only 2 classes. That is fine. But the architecture that they have, you want to use that pre-built architecture. In those kind of scenarios, what we would do, we would take that model. So if I depict the model by M, I would take the pre-built model and I will use this model. I will just modify it. How, what I mean by modification is that entire model. So let's suppose I can just make this as the model. So this is the input part, okay? And this is the output the model is giving. And this is where it is actually telling me that how many classes are there. Suppose the model was built on 10 classes. Okay, 10 classes as in yesterday. Why I'm saying 10, it could be any number of classes, but I'm saying 10 because yesterday we saw 10. So those were numbers from 0 to 9. So if suppose we have 10 classes, now, in the current use case, we have different number of classes. But what this net is doing initially, the way it's identifying what kind of image it is, we want that kind of processing because they have trained on a very large data set. The weights are already trained. We want to use it because we cannot retrain the model because we might not have that much sufficient computing power. Organizations like Microsoft, Google, they have that kind of training hardware to train models on that scale. So they have already trained it. And if they have already trained it for maybe weeks or maybe for months and the weights are already there, you can directly use those weights. Only thing that you need to worry about is the output layer matching? Will you get the same kind of result for your current data set? In that case, what we would do, we will take this part, we will remove this part. Okay, so this part we will remove. In place of this, we will add our own layer. We will add our own layer and we will give it an output, and we will train only this layer. Based on our data, we will train only this layer. The entire layer from this point to this point, we will not train that. We will keep it fixed, what is already present in the model. We will only train this part. And just by training this part, we will be training this particular model for these classes on our training data set. Now, this type of technique is known as transfer learning. What are we transferring? We are transferring, if we have a very big model, which we cannot train on our hardware, and we are creating our own model, but we want to use the knowledge that that model has. So this is what known as transfer learning, that all the knowledge that the pre-built model had, we are transferring that to our model, and then we are using our data set to just optimize the output layer, and then we can see what the results are. So this is one thing, because there are so many pre-built models already existing. There are so many open source models, and you should definitely try to use those models before you build yours, so that you know what kind of accuracies the state of art models are giving you. And if you can improve, or maybe if you want to create a product in your company, if you want to create a product, and maybe then you're thinking of selling that product later on, you should know what kind of accuracy pre-built models are giving. And based on that accuracy, you need to create a model. You need to modify that model, or maybe you need to create a model from scratch so that you beat this model. So that is the reason you should be aware of that what kind of accuracies or what kind of performance the existing models are giving on your particular use case, not on the use case what it was trained on your particular use case. So this is what we will be seeing. Yeah, so let's start. So I will just share my screen again. Yeah. Yeah, I've shared my screen. I hope that's visible. Yeah, transfer learning. Okay, so let's start with that. So first of all, in the initial phase, I will just put in some imports from my pre-built script. So we are not worrying about the import part here. I will just tell you what I'm importing. But the focus, the entire focus, we will be putting on the kind of model we have. If suppose we have a pre-built model, how to use that pre-built model, how to import that pre-built model, and based on that, how to remove the layer or how to add a new layer in the end so that we can actually train that specific layer for our use case. Okay. So the initial part you don't need to worry about. Right? Let's see. So I will be pasting just this part, the initial pre-processing part, and later the model building phase, we will definitely write it together. So these are few just imports. So what we are importing: early stopping, model checking, one hot encoder model. These are the layers. These are all fine. Anytime you have a doubt, the best resource to go is TensorFlow. Anytime you have doubt, just go here, say API. You can even run, suppose if you're working on a project since a very long time, then you might not have TensorFlow 2.4, then you might have TensorFlow different version 2.2 or 2.3. Then you can go to that specific version and check what all fields are there or if something is changed or not. Okay, so now if this is imported, first of all, always check your runtime. Okay, now it's none. So I will just change it to TPU and save it. So as you change the runtime, it will start the entire kernel again, and it's just initializing, and then we need to run it again. If I don't use a TPU, it might take a very long time for me to train any model. But today we won't be focusing on the training part because we won't be training the entire model. We would be training only one layer. So based on that, it should be much quicker than yesterday. The part that I'm pasting, we are just importing the data from a Google source. You don't need to worry about all this. This is just pre-processing. That's why we are not focusing on this. Our focus is to know how transfer learning works. This is just a way to fetch data. And this is very similar, or maybe you must also have done something in machine learning also while building machine learning models. So this is not the point of focus. The point of focus is how we are doing transfer learning. So we will just focus on that. And then if we do have time in the session, then we will actually cover this part also. We can come and see that how, from which URL we are taking data, how much data we are taking, and other things. So this is just a data with images and labeled images. So that's why we are doing supervised classification tasks. So these are dog images and cat images. Okay. So our task would be just given an image. You need to tell us, is it a dog image or is it a cat image? It's a very simple problem, very simple problem. But let's continue. So now this is done. So after that, we want the model. Okay. But before getting the model, we need to worry about two things. So now we will be working with mobile net. I will show you. Yeah. So whenever we come here, you can actually come to TensorFlow Keras applications, and these are the models that you already have. These are the pre-built models. So there are so many pre-built models. What we will be looking at is MobileNet. Okay. Now MobileNet, whenever you come or whenever you actually think of using a pre-built model, it's very important to know about the architecture of the model. Okay. So you can just go and check the architecture. That's fine. Always come here and check, is there any pre-processing that you have to perform while using the model? Why I'm saying this? Because the model is already trained. Now, one more thing, I already told you that if you click on this part, you will directly go and it will redirect you to this research paper. So you can directly go here and check the architecture. It's always good to check the architecture first before using it. If you're using it for maybe a very small use case or just for some demo purpose, it's fine, directly use it. But if suppose you want to build an application, if suppose you are researching into something, then it's a really good practice to go and read the architecture from the research paper itself. Now, when we come here, the second most important thing is always see if there is some pre-processing required. Why I'm saying this? Because whenever they were training model, they had some pre-processing and then they trained the model. So the input that they passed to the model was supposed to be in some peculiar format. Okay. What they are saying, if you want to pass the input, your data set, your input, we have no issues. Only use this part, the pre-processing input phase. Just use this in your use case and everything will work as it is. So what are we trying to say here? That if we are using it, we should, I will just say, yeah, transfer learning. So transfer learning, yeah. So we need to use the same pre-processing what they have introduced. Okay. So for that, it's very simple. We can just use, so pre-process input. Okay. Pre-process input. Okay. Then I can say from TF. TF is, we have already imported TensorFlow as TF. That's why I'm writing TF. From TF, Keras, and then we have application. Okay. Then we have MobileNet. Yeah. So there are different versions. We are saying V2, and then I will say pre-process input. So what I am saying, that this pre-process input will get that particular function that we need to pass. Okay. We need to pass all our inputs to this particular function so that the kind of input this model was expecting, our input also follows that pattern. Okay. This is done. Now let's, okay. Now let's start in getting our model. Fine. Okay. So I will say this is our base model. Why am I saying base model? You can say base model, you can say custom model, you can say your model, you can give a different architecture to your model. For this session, we will be saying it's our base model. Okay, so base model tf.keras again. So from keras, we will go to applications, and from applications, I will say I want the mobile net v2. Okay, this is one part. Now, if you see mobile net v2, there are multiple parameters that we might pass. That do I include the top, what kind of weights that you want to use, and other things. Okay, so few things are important, so we will pass only those. Okay, there's one thing that is the image shape. You don't need to worry about that. Image shape is a tuple. I will just say image shape. We will definitely discuss it, but don't worry about it right now. Let's focus on one thing. Once the model is trained, then we will talk about nitty-gritties in between. Okay, so this is just the input part. Yeah, fine. This is just the input shape that we are giving to our base model. This is how they expect it. That's why we are giving it. Now we will just say what kind of input shape is. So that's why I've just created image shape here. Okay. The other thing that we would give include, there was one parameter. See, you don't need to remember all the parameters because there are so many parameters. So whenever you're typing, just go through the TensorFlow page, or you can just come here and check. So this, it's include top. So I will just say, I don't want to include my top. Okay. Why I'm doing that? We are doing that because in the diagram I told you, I will be removing the last part and I will be putting my layer and only then retraining it. Okay. So if I want to remove it, I will say don't even include it, and I will only include it. Okay. And I want weights. Yeah. If they will say, do you want weights? Yeah, I want weights, and those should be of ImageNet. If you don't know these parameters, just copy, go to TensorFlow, just copy this part and say, yeah, please give me weights of this pre-trained model. Okay. And let's run it. If there is some error, we will get to know here itself. So what it is doing, it's downloading the model from TensorFlow, wherever the model is kept. It has downloaded the model. So this is successful. Now let's go and check. But before checking, we created a model. We had few layers yesterday. Okay. Let's see how many layers are here right now. It's very good to always go and check the architecture first and then come here so that you already know. But let's see. So we will say base model and we will say summary. Summary is a very good way to actually check that what kind of model it is, how many parameters are there. So now if you see, there are so many layers. So this is the layer, this is the starting part, input layer. Okay. Just by the input layer, now you know, okay, your input is taking, none is just depicting that it doesn't care that how much data you have. You might have 1,000 images, you might have 10,000. It is not worrying about that. What it is worrying about is the size of the image. That is the shape. So it's saying I want an image of 160 by 160 and it's a colored image. So that we have three. Okay, three channels. And now see the number of layers. There are so many layers. If you are starting, or maybe if you're creating a model, we generally won't use so many layers. And even if you are using so many layers, you might not know what kind of layers to use at which point so that your network is performing much better. Okay. So that's why it's much better to use the pre-built models, check what they are doing, and then based on that, you can create your own model too. So see, the number of layers are so many. Now, after that, let's go in the end to check how many parameters are there. There are so many parameters. Whenever you see number of parameters, always check the trainable parameters. Why? Because these are the parameters that would be trained once you start training your model. So if you have more number of training parameters, so definitely the training process will take that much time. So this is very important. Okay. So we don't worry about the non-trainable parameters because those are not trained in the training process. So that's fine. We are worrying only about this trainable parameters. That's fine. Okay, let's continue. So now what we would do is we need to supply the data also. Now, I don't know that if you guys know what a batch is. A batch just to visualize it, if you have suppose 1,000 images, or maybe if you have 100 images, just to keep it very simple, if you have 100 images, now you are saying that 100 images you will split into small chunks and then you will pass it. So that small chunk, you can just think of it as batch. You're passing small batches to your model for training. Okay. Now there is something that whenever your model is asking for it, you can give it in a iterative fashion. So you are iterating one batch and then you're giving it. Then you're iterating next batch and you're giving it. You're not giving the entire data in one phase. Just because of that, we will be using this. I will just write it. Image batch. Image, batch. But if you don't if you have not trained the model in batches, or if you have not created batches, or if you don't know what batches are, don't worry about it. This is not the point of focus. The point of focus is how to do transfer learning. Okay, so don't worry about this. So image batch and label batch. I will say not labels, I will say label batch. And what I'm saying, I want it in a iterative fashion. Okay, and from where I will say from my training data. Okay, that's fine. Yeah, that's fine. Okay. And one more thing, I will say what is my feature batch. Okay, let's do this. And if we, yeah, this is set. Don't worry about this if you're not very, if you don't know how batching works, don't worry about this. This is not the concern point here. The concern point is something else. Now, the most important part over here is that the trainable variables. There are so many trainable variables. Now, what you need to do here is that you want to train only your last layer. That means you don't want to train all this. For that specific case, let's go and check if there is something. So if I go and check, we will go to Keras, we will say model. Okay. So for any model, we should have a proper trainable. I will just check if it's giving us here or if it's very model specific. Okay. If it's not here, I will just directly show you while we are coding. Not an issue. Not an issue. What I will do is I will just come here, and what I will do, I will just model. So our base model we know. So I will just say base model. Base model summary we have already seen. Okay. I will just give the summary again so that we know. Okay. This is the same summary. Okay. It's here, so it's visible. I don't need to do it. Yeah. So what I will say, base model, I will say I don't want to train it again. Yeah, we have this parameter. Trainable equal to false. Just by saying this, what are you trying to convey? You are trying to convey that please don't train this base model. I don't want to train it again. Whatever weights are pre-trained, I want to keep it as it is during the entire training phase. The other layers, I would not give the trainable as false. So the other layer that I would add will have the trainable parameter, and that parameter will be set to true by default. And only those layers would be trained while training. Okay. So if suppose if I say false, I will definitely print it again. So I will just say base model. Yeah. And I will say summary. Okay, let's see. Yeah. So as soon as you say, please don't train my model, what is this doing? It's saying trainable parameters are 0. That means during the training phase, I won't train any of these layers. Okay. These layers won't be trained. Fine. What will be trained, that we will be adding. That is fine. Okay. I hope till this point it's very clear, and I think so it's very intuitive that what we are trying to achieve and what we are doing over here. Okay, let's continue. And while we do this, what we will do, Now we will be creating our own layer. Also, one more thing, I told you yesterday that we could actually do the entire thing, creating a model using sequential, as well as there's one more technique. You can think of it as model chaining. We can create it by that. So today I will be creating our own model using model chaining process, or maybe the other style of it, so that you would know how to create it using the sequential API and even the today's approach. Okay, so now let's, for our custom layers, I would say custom layers. It is clear. Okay, now for custom layers, I will just have, yesterday we used max pooling layer, right? Let's use global average. I will just say average layer. Yeah, and I need to check if, which it's there. I will just go to Keras, and yeah, Keras layers, and I will just say tell me the global average layer. We want the 2D. Yeah, yeah, global average pool. Okay, we have that. So I've taken that. Okay, one layer is done, and there is a typing mistake. Global average. Okay, till this point it's done. So we have taken this layer. We have not used it anywhere. We are just taking it here. We have not used it yet. Okay. Now let's take our prediction layer that we would be attaching to the pre-built model. That would be the prediction layer. Okay, prediction layer is fine. Prediction layer, again, we will go to TensorFlow. We will say from layers, I would take just a dense layer. Okay, and for now, I need only one unit because I'm giving only 0 or 1, that is cat or dog. Okay, this is fine. If there was any error, we would have known at this point itself. So now this is very clear. Okay, let's go and now create our own model. So while creating the model, you need to give the input. So you will be telling that this is our new model. I will be using the base model and I will be attaching something. So what I will be attaching is our custom layers. Okay. And then you need to give the input shape as well. So that we would be doing. Our focus is here right now. So let's come here and say, yeah, I will just say building our custom model so that it's clear that what we are trying to achieve here. So let's say inputs, okay, and I will say from TensorFlow, Keras, yeah, and I will say please give me input, and I will just say the shape, yeah, shape of my input that we have already seen. Why I'm giving this shape? Whenever you have a doubt, always visit the summary of your model. Once you visit the summary of your model, you would know what kind of input the model wants. That's why it's very important to always print the summary, check the model architecture, check the inputs, and in between, if you have some doubt that what this layer is giving out, then you can just check the output shape here. And in the end, always check the trainable parameter that we have already checked. Okay, so this is 160, sorry, 160 and 3 because our images are colored images. That's fine. So this is the input part. We are fine till this point. We are very clear that what we are doing and what we are trying to achieve. Okay. Let's say X. I'm just using some arbitrary X. You can say layer, you can say anything. I'm using X. You might use a different variable. Okay. Sorry. Now, these inputs, okay, this was a very important point when we were talking about, this is MobileNet v2, right? So I will just go to TensorFlow Keras application. Okay, let's not go again and again, but I will tell you from the code itself what we were talking about. We were talking about that there has to be some pre-processing on the input. Okay. Now this pre-processing, what they have, the creators of the model, they have said, you don't worry about the pre-processing. Whatever your input, just pass it to the pre-processing phase. We will pre-process it for you. just maintain the shape properly. Okay, that's fine. So that's very easy. So what we would do, we would say pre-process input. Okay, so whatever pre-processing, just apply it on our input. Okay, till this point it's clear. Now there's one more thing, that what name that we have given to our model, that is the base model. So the current MobileNet V2 model that we have imported from TensorFlow, you can say model zoo, or maybe some place where all the models are stored, that is there in the base model. Okay, so what we will do here, we will just directly use that base model. We will say x is equal to the base model. Okay, base model, I will just pass the input as x, that what is being passed to what is being fed in the base model, that is this pre-processed input. Okay, this is very clear. And I would say again, just to be safe, training. It's not, oh, it's, okay, it should actually give us training. Sometimes it won't. Okay, so now we are saying that to the base model we are passing this x, that's the pre-processed input. Please don't train that. And then we are again giving it x. It is just a variable that we are overwriting. If you get confused with this, what you can do is you can say layer 1 and then you can say layer 2. But the problem with that is if you have multiple layers, then it will keep going on. So that's why I'm just overwriting it. But if you are very comfortable that, or if you want to make your code very readable, then you can go and use it that way. Okay. Till this point, it's very clear. Now what we have one pooling and one prediction layer. That's the dense layer. That's good. We just need to attach it. Now this is the point that I was telling you guys yesterday, that what we are trying to achieve here. This is fine. Don't worry about this part. I'm just overwriting it. That's fine. I will just give a space so that it's get emphasized. What we are trying to do is that we are trying to use our current layers, average layer. Okay, and what we are passing to that layer is the input. Okay, for now I will just say input of previous, so that you know. This is how I am chaining. So what is happening, this input is getting passed here. Okay, this x is getting passed here, this x will be passed here. Sorry, not input, it should be output. Okay, so this x will be passed here, and this is how the model structure is getting defined. So it knows your data is flowing like this from this point and from this point. Okay, so our output was x, so I will just write x. I hope this is very clear. Let's remove the space in between so that it's quite readable. Okay, after that, I've already told you about dropout, so let's have a dropout layer also. Okay, so I will just say x is equal to tf dot keras dot dropout. Okay, it should be dropout. Yeah, just a second. It should be in. Okay, sorry, it should be in layers. Yeah. So yeah, so things like this. If suppose you don't get where dropout is, it's very easy. You don't need to type and even wait for it. Just go and say dropout. Okay, once you come here, it will say dropout and you will directly get where it is. So Keras let's dropout. Best thing is just copy this and paste it. But if your IntelliSense is working, then you can even use this. Not an issue. Okay, dropout. Fine. Now dropout has one parameter. So let's go and check that parameter. The rate of dropout. Now the rate of dropout, okay, the rate of dropout, they have used 0.2. We can use 0.2. So based on that rate, it will keep dropping your values. So let's use what 0.2. If you are not very comfortable, if you don't know the rate values, always go and check what they are using. These are some predefined values which would work on every model, which would work on your use case as well. But if you want to have some specific thing, then use your own parameters. So dropout, I'm saying 0.2, and I will be chaining it so that the output of the previous should be given here, and that has to be dropped out, and I'm just overwriting this variable. I hope this is quite clear. After that, Let's have outputs. So now what we have added only two. That's the only part we are adding. So let's not complicate it. I will say outputs equal prediction, because this is the layer that we would be using. So prediction layer, yeah. And I will say I will be passing input of the previous layer's output. Okay, till this point it's fine. Now I will say this is my model. Okay, now what is this model? This model is actually, we are creating the model from the model API. So model, so I will just say tf keras dot model. So this was another way how you actually create a model. So it's better to actually go there and check, so that yesterday we were using sequential. Okay, so this is one way that you club or stack everything. So this is the way, linear stacking of layers. Okay, what we are using today is the model approach. What model approach is doing, group of layers into an object with training and inference. That is fine. So it's just to visualize it, it's just a chaining way. If you don't know how to use it, it's very simple. Just come here and see small examples. So these are just generic examples. So you will come to know, okay, giving the inputs over here, and then the output of the previous layer should be the input of the next layer. That's it. And then you can try it in your application. Okay, so this is one of the approach. In this model, there are two things. What are the two things? Okay, they have not mentioned it here. So what are the two things? This is the model. You need to tell the model what is the input and what is the output. So we will just tell it the inputs are the inputs. Inputs are the inputs, as in this input. This is the input that this model will be getting. And what kind of output it should be producing. Okay, I will give the outputs. Yeah. Okay, so this is how this model will be created, and we would be storing it here. I hope there is no doubt till this point. Okay, let's run this. Okay, it's giving an error. It's saying pre-process input unsupported float. I will just check what happened. Pre-process input. Oh, this is just a typing mistake. Yeah, that's what I was wondering, that it shouldn't give an error at this point. Maybe it might give us some error at a later stage, but not here. So yeah, that is complete. I hope everything is clear at this point, because this was the crux that we were doing. I will just briefly explain again what we are doing. We have just used the model. We have set the model, all the parameters of the base model as trainable as false. So that made all the trainable params as 0. After that, we have created our custom layers. Why are we creating our custom layers? Because we are creating our custom layers so that it works on our use case. It works on our data set. Just because of that, it should work on our data set. We have to train the output layer. For training the output layer, we have created these two layers, and by default, these layers are trainable equal to true. So once we start training, only these two layers would be trained. The entire model, the base model, won't be trained at all. Okay, I hope that's pretty clear by now. Okay, this is done. Now, before that, we need to tell that while training, we need to compile the model first, that how should it train, what are the optimizers, what are the loss function, and what are the metrics. The loss function, I guess we have discussed it yesterday also. Loss function is just giving you an intuition to the model. Okay, this is the loss function. This is how you need to check that are you doing a good job or are you not doing a good job. You need to optimize it more or something like that, just for an intuition. So I would just say compiling the model. Okay, so this is fine. Now let's say model dot compile. Yeah, okay. And there will be few fields by now. I hope that you might know because we have used it. Optimizers, I can just say Adam. Again, I would tell you, I don't know if everybody was present yesterday or not. If they were, then I had already shown what Adam is. And There were other optimizers as well. You can actually go here and come at this point, Keras, and then you can go to optimizers and you will get to see the entire list. What we are using is Adam, but if suppose in your use case, you might feel that you want to use some other optimizer, you can definitely use that optimizer. Okay. Just to keep it simple, I will use the same kind of compiling steps that we used yesterday so that we only focus on the goal. Our goal is to know what transfer learning is, how do we achieve transfer learning, and how easy transfer learning is. And just by using transfer learning, we could get exceptional results even without training the entire model. That's a very big deal. Okay. Now loss. Okay. I yesterday what I was doing, I was directly using this as just a name. So what it's doing, I will just tell you, I will go to add-in and I will go to Adam and you can just use this name just by using this name, and inside the code you can just use small a also. It takes Adam. Okay. This laws, there is another way you can use Adam in this way also. This is what I told you yesterday. I'm just repeating it again. Okay, if I use it this way, it will also work. But just for simplification, I know this will also work, so it's fine. But for loss, let's use a loss from, uh, okay, sorry, not from Keras, tf.keras losses. Okay, and we have a binary, yeah, binary cross entropy. Okay, this is fine. If you have any doubts, you can just directly go and check losses. You will have all these kinds of losses. Okay, so we are using binary cross entropy loss. Okay, so this is fine. And if you want to actually read about it, you will have all the examples from logics where so if you want to know what the arguments are, you can just go through the arguments. Okay. There are so many arguments, so we cannot cover each and everything in depth. But if you are giving something, then you can actually come here and check. And if suppose you want to change something, maybe label smoothing you want to check, just copy it. Okay, let's just copy it. I could have used it directly via name, but for now, I'm not using it like this. But let's suppose we want to change something. Let's change. I just want to use it this way also so that you know that you can use it. If you want to pass, see in this, you cannot pass a parameter. And if you want to pass a parameter, let's just say, okay. So this is how you can actually use the same thing and pass the parameter also. Okay. And let's one more thing. We want matrix. We definitely want matrix. So if you don't remember, you can just directly copy matrix portion from here. And matrix is a list. Matrix. I'm really sorry. Yeah. Matrix. Now this is a list. Now this is a list. Always check what kind of matrix you might have. Yeah, you have so many. Fine. It entirely depends on your application, on your use case, that what you want. Okay. Just to make this simple, I will keep it very simple and I will just a second. Just to keep it simple, I will be using the same accuracy one which we used yesterday. Okay, I can just use the name accuracy. Oh yeah, yes, that's correct. Okay, if any doubt why I'm using just accuracy, it's the same way that we were using Adam. If you have any doubts, I don't know if they have given the accuracy in that way itself, but there are certain ways which were, yeah. So you can just copy it from here and you can just paste if you don't remember. So you don't have to always remember things. You can just go to the TensorFlow page and directly copy it from there. We have compiled. We have not compiled. Yeah. So we have given this is how the model should be optimized. What's the loss function and what is the metric that I'm looking for. Okay. After this, this is a very important step. That is the model summary. This will give the entire summary. Okay. So our model, so entire thing. Now you might think, okay, it's a very small thing. It's not very small thing. The entire input part is depicting, this is the input. And then this is the layers that we have added. So it's showing you that what have you added in between. You're using MobileNet V2, and in the end, you're using a global average pooling. That's fine. And then you're using a dropout. That's also fine. Then you're using a dense. That's also fine. The most important part is see the number of trainable variables. You have so many parameters and you are training only the layers that you have added. This is the most important part. Now you need to train only maybe 1000 or maybe 1.2k parameters, and it's very small. And this will definitely improve your training process as well. And what advantage that you might get, that MobileNet V2, the architecture that they have created in a manner so that it identifies more kind of features in the image. So you're getting those kind of features for your specific use case, and you have to train only 1.2k parameters. That's definitely incredible. And just by seeing this, you might be thinking it's very easy to create your own application using a pre-built model. Just take that model, pre-process your input based on the pre-processing steps they have given, and just add your output layer and train your model on your data only for the output layer. That's it. Okay, now this is clear. So let's now go and start the, yeah, model.fit. Now model.fit is fine. Yeah, fit is fine. But before that, I told you that it actually outputs a history object. So we will store it in history. If suppose you don't want to actually check that while training what was happening, you can skip this. You can, you might not store it in history object. That's totally fine. But now, just to print out the graphs that how was the training process performed, how was the accuracy during the entire training process, how was the loss during the entire training process, I'm just storing the system model. And once the entire training is done, we will just see from the history model that what kind of things we are getting. Okay, model.fit, this is fine. I'm just passing the training data, that's fine. And I will just say epochs. If you don't remember things, directly take from here. I will say epochs and I will say, okay, it's 330. That's why I'm wondering how many epochs to take. Okay, let's keep epochs maybe at 10 or maybe 8 for now. Okay, because otherwise it might take a longer time and then we need to wait for it. That's fine. And I will say I already have validation data. So yeah, validation steps, not validation steps. Yeah, I already have validation data. So I will pass you the validation data separately. You don't need to split it. Okay, this is fine. So what we are doing here, we are just passing the training data. We are just passing the validation data and we are saying, please train it for 8 epochs, keeping the optimizer as Adam, the loss as binary cross entropy, matrix. What I am looking for is the accuracy. Okay, let's start training the model. Let's hope it trains pretty quickly. Let's see. Okay, and the accuracy keeps on changing. So we won't be worrying about this accuracy at one epoch. Let's start writing the other part of the code. Other part would be to print or maybe to show the plot. So let's start doing that till the model trains. And then we can come back to this point again and see how the training process went on. Okay. So I'm actually worried about the accuracy. So let's worry about the accuracy. So from the history object, okay, will it give me IntelliSense now? Okay, so the kernel is busy at that phase, so most probably we need to type everything, but that's fine. We have the time to type history. Okay, yeah, and from that I want to get accuracy. Okay, till this point it's fine. And okay, it's going for the second epoch. Now, are you seeing the validation accuracy over here? Now, just by looking at this, you might say, okay, let's keep on training and check. But this is how, if you're using a pre-built model, even in the starting few initial epochs, you will get a very proper value. Proper value as in you will get a decent amount of accuracy. Yesterday, we were trying in the MLP model, we got around 56%. Then we used a CNN model. I guess we got around 60, 70, or 80. Yeah, we got around 80%. That we created our own model. This we didn't create, we just used it. We just gave the last, and this is the kind of accuracy that we're getting in the initial epoch itself. Definitely, this might also be dependent on our validation set, definitely. But this is the game that you're trying to see. Just because of this game, transfer learning is so famous that people are using transfer learning to use the pre-built model trained by Google and even OpenAI and different organizations, Microsoft, OpenAI, Amazon. Yeah. So till then, till the time it's training, it's already third epoch. See,
Can you tell just one thing?
yeah,
Yesterday you saw show that na checkpoints and all that, and you
yeah,
told that na you can reuse that model once
yeah,
you save. And
yeah.
can you show that example? Some checkpoint using some checkpoint from how to write or how to use that
Okay, okay. Do you
already
want?
trained model or saved model, or from that checkpoint how to reuse means I have stopped some time and after another day I want to start from that point, so how to do that
Okay, okay, okay. Not an issue. I am just sharing my screen. I will just share my screen. Yeah. Is it visible first of all?
yes, yes,
Yeah, so this is yesterday's example, okay?
yes.
In yesterday's example, in the end, I am actually thinking that we didn't have a lot of time in the end. That's why I couldn't go through this part of the code. But what we were doing, we were just saying model, load weights, and I was giving the checkpointing model. What was this? This was the path to my model which was saved.
Can you
So
show
what?
that checkpoint MLP
Yeah,
where it is
yeah,
written?
yeah, yeah, yeah. Definitely we can go there. What we will do, okay, I will just show you CN or do, yeah. So we were saying this is the path. So if suppose you are storing in your drive, that would be some folder and maybe some folder two, maybe folder two and this. So this is just the path of the file, okay? And you will say, please checkpoint my model to this path. Is this clear?
Yes.
Okay, and just this path, using this path, what you will do whenever next time whenever you log back in, maybe after a day or two, you will just say model load weights from this.
But where is this variable checkpoint underscore MLP?
Oh, this is not a variable, this is just a folder structure.
Okay, that path.
that
But
path that path so it will automatically go to your drive, go to the second folder. From there it will check, okay, is the model present? If the model is present, it will automatically load the model.
okay. So
Okay.
same way I can use my that .h5 file and all that.
Yeah. Same way, exactly same way. You can just load the weights. You can checkpoint it every time. You can save only the best weights. And
Yeah.
every time you want to start retraining the model, you can just go and give the path of your model. You can just say load weights. So now you have the model again, and you can just start training the model again. So the initial weights that the model would be using would be the last saved weights that you had been using earlier.
I want to ask you one thing.
Yeah.
See, this is the, for example, these saved weights.
Yeah.
For example, I have some flower data set. There
Okay.
is flower data set on net. Na?
Yeah.
So, for
Yeah.
example, I have trained that my previous model for five
Okay.
classes.
Okay,
So,
okay,
and I have saved that model. So that model
okay.
is for trained for that five classes, right? And
That
now,
five specific
yeah,
classes, yeah,
and
yeah.
now I want to train the model for different another 5 or 15 classes, so can I use my that model,
Okay, that's a very
that
good
weights,
question.
that
Yeah,
weights
yeah,
can I use for this next another 10 to 15 classes?
yeah. That's a very good question. Now I will tell you how to think about it. So suppose your first model was created on a flower data set. Okay.
Yes.
Now, the second model that you're trying to create, if it's on the similar lines, maybe a flower data set, maybe of some different flower, or maybe some different kinds of flowers. If it's on the similar lines, what have you stored in the model? The model, you are getting the features. So the first model is trained on flower features, that how to extract a petal, how to extract a stem, how the flower looks. You have extracted that. So the weights represent that. So if your second application has some implication of those kind of kernels or those kind of features that you want to extract a petal or maybe the flower shape, then you can definitely use it. But if suppose your second model is identifying a face or maybe identifying a different kind of cars, then the first model was actually thinking of the kernel that were trained or the weights that were trained was to extract features such as flowers. But the second model is for cars, so you cannot actually use it. So whenever you are using it, you need to think about what your base model was trained on. And this is the only thing that because of this, what Google and Microsoft are doing, they are training with lot of data and lot of classes. So they will be training a model with maybe 100, classes so that it covers your set. So maybe they have 100 classes and later on you want to use it for maybe 10 classes, but that 10 classes will be from this 100 class set so that you can easily use transfer learning. But if suppose it's not an overlapping or if the application is entirely different, then I don't think so transfer learning would be feasible in your case. It would definitely work, but the kind of advantage that you're trying to achieve from it, you won't get it. Because the kind of features the model has already extracted are not for the kind of application that you want to use it for. So that's the only thing to keep in mind.
Okay.
Yeah, I hope that's clear. So this is the way you load the weights, and as soon as you load the weight, you can just directly start using the model again. Fine. So I will just remove this part. And where were we? We were here. Okay. So yeah. So now all the 8 epochs have been trained. Yeah. And if we see the validation accuracy, that's close to 98%. Just by using our layers. Why this worked? Because mobile net model must have been trained on cats and dog images as well. Now, if suppose the data set or maybe the classes were not overlapping, or maybe the kind of training that might have been done, maybe on a very different data set, maybe on cars, then I cannot directly use it in our use case because the weights that have been trained, those are to identify some specific kind of features, and that should be common. Only then you can use transfer learning. Okay. So let's go and check the accuracy. So in the history object, we must have stored everything. So in the history object, we have accuracy, and we will say some random part, or I should just directly write it. Okay. Accuracy. So we are worried about two things. One is the validation accuracy and other is our own accuracy. So I will say I'm worried about the validation accuracy also. So I want to know from the history object, history.history. Yeah, and I will say val accuracy. Yeah, val underscore accuracy. Yeah, okay. Okay. So now we are getting that. After that, we are also worried about the loss, but let's check the accuracy first and then we will be worrying about the loss. Okay. Now I will say I want to plot a figure so that we could visualize it, and I will just give figure size. So I will just take from here. You can just take it from here or you can just type it from IntelliSense also. But I'm just showing you different ways so that you're aware of it. Okay. And then I will say plot. I have some subplot. Okay. No, let's not go for the subplot right now. I will just plot one thing, or let's plot both the things so that in one plot itself we have both the plots. Both the plots as in the accuracy plot as well as the loss plot, so that we can actually see the model properly. Subplot, okay. And I will just give this. Don't worry about these. You can definitely get these from anywhere. Or there is one more thing. There is something called as tensor board. Also check that. While you're training the model, there is something called as tensor board. So you can actually visualize what layers are doing and you can get into depth. So if suppose you get some issue somewhere, so your model is running properly, but you're not getting a correct accuracy or maybe desired accuracy, and you want to know what individual layers are doing, then actually go and check tensor board from TensorFlow itself. There you can actually manually go and check each and every layer, that what the layer is doing, and then you can actually check, okay, this is the problem, I need to fix this layer, or I need to add something before this layer, or I need to pre-process something to correct my error. Okay, that is one more thing. I didn't share it yesterday, I just realized it now. So I will just plot it. Okay, so I will just say plot. I want to plot my accuracy. Okay, and I will give that as label. So I will say label is equal to train accuracy. This is fine. Okay, this is a very basic step. We just want to see it. That's why, and I will just say val accuracy as well. I want to val accuracy, and I will just say validation accuracy. Till this point, it's very clear. Okay. After this, this is just to make it fancy. I will just say legend. It should come. It takes a lot of time sometimes. Legends are just the legend that you see that what curve is doing what. Why I'm actually even going in this detail, because plotting these curves after your training, it's really important to get to know that at which point of time the model was doing a better job, at which point of time it failed, and then you can think, okay, why it failed after this time. Then you can go in depth and check your error. So that's why it's a very good practice to uh, at least check your validation loss and validation accuracy. So yeah, training and validation both. So I will just say location. So location should be anything. I will just say lower right, so that we can see, because our accuracy should go up. That's why I'm saying lower right. This is fine. Yesterday we didn't focus on this, so today that's why we have time. So I'm focusing on this also. I will just say while label. Yeah. So while label should be the accuracy, because we are printing the accuracy. This is fine. And what I will say, the while label is done. Plot. Yeah. And do we have a minimum value? Let's give the range is also while limit. Yeah. Okay, and let's give it a value of min. Yeah. Okay, min and the plot. Okay, just a second. Yeah, and the while limits. Fine, and the second parameter. This is fine, and I will just say plot dot title. Yeah, this is the only thing that we need to worry about. Title. Yeah, let's check if this works or it's giving some error. Okay, I will just worry about that error. We will just see that, not an issue. But the point that I'm making is that this is your, I will just copy. Yeah, yeah. So this is how training is working. Okay. So orange line depicts your validation accuracy and the blue line depicts your training accuracy. And this is how it's increasing. Now, if you see the point here, that it's 98, 90, it starts from this point. This is how transfer learning is actually helping you. Now, I know transfer learning will only help you if the base model has something or some features that you want to do right now. It is identifying some kind of features that your application has right now, but you can select an appropriate model for that. Okay, this is one thing. And let's just check. Okay, I'll just comment it and check if I don't give limits. This is also fine. Yeah, and I will do one more thing. That would be this part. I just say train loss, and okay, that okay. I haven't taken that. Yeah, I will just take that too. So I will just say my loss is the training loss. One would be the validation loss. That is based on the validation data that we have given. It's very important that you know what that is. So I will just say loss, and I will just say val loss. Yeah. Okay, and train loss is fine. This loss is fine. This is just to print it. Location is fine. Lower right is fine, but that would overlap. I could just say upper right also. This is fine. Like, this is just for printing stuff, nothing else. And I'm just saying, just let's check if I've copy pasted everything. Yeah, loss is fine. Okay, just I know I can just correct it there itself, but just paste it here. So this is a loss, what you're seeing. and this is everything together. So I would just remove it from here so that we can see both. Okay, so this is the accuracy that you're seeing. Okay, it's also printing the, it's not printing it properly, just a second. Okay, the limits that I've set, but that's fine. We won't be worrying about it. It's already 3:45. The point that I wanted to make, this figure, it's fine. This figure we can actually check later on also. Loss should decrease, but if you want, I can just take it from a pre-built workspace if you want it, so that you have seen exactly everything properly. Yeah. So this is the point I was making. Always check that what kind of accuracies that you're getting from the default space, and always check the kind of loss that you're getting from the default space. Now your loss is starting from a very low range. Your accuracy is starting from a very high range. It's a very good sign to have. Okay. This is how it works. I hope that I have cleared all the points that we have covered. I know we have trained it only for 8 epochs, but I did it because yesterday we trained it for 10 epochs and we were over time slightly. That's why we have trained it only for 8. But whenever you're training your model, you should train it for large number of epochs. Then you might get it a substantial accuracy. Now we are getting it very quickly because even the data set, I don't know how many data points there are. So the kind of data set that would vary, the kind of application that would vary, but this is the kind of thing that you would just increase the epochs. Now you cannot always train with maybe 200 epochs, maybe 300 epochs, because that would take maybe 10 hours, 15 hours. In that case, just train it with 100 epochs. Okay, save the model. Next time when you log back in, just load that weight, load that model, again train it by 100. So it will give you the same kind of result what you were getting it from training for 200 epochs. That is one very important point. Otherwise, training the machine learning model, deep learning models, especially deep learning models, again and again, it will take a lot of time. And this is the thing. Why transfer learning is important. Okay, so I'm summarizing the entire thing, entire session in just 2, 3 lines. So transfer learning is important because first thing, there are so many parameters, but in my use case, if I use that model, I need to train only few parameters, only the output layer that I have added. First point. Second point, the kind of architectures that have been already created, I would take a lot of time, maybe few months, maybe more than that too, to get to this kind of an architecture and then think of improving it. Better than that, use the existing architecture and check what kind of accuracy. Okay. The third part is that you are getting the gains that you are not seeing yesterday. In an ideal case, we would have 3 sessions. One is MLP, CNN, and then transfer learning. But we saw both tools, the two of them yesterday, and now you know why transfer learning is important. Will transfer learning help you every time? That's not the case. Always check the model architecture, always check the model, and always check what the model was trained on, what kind of data it had, what kind of classes it had while training, and only then you can think of using it for your use case. If your use case is very different from what it was trained on, then transfer learning won't help you. That is the only reason big organizations are taking a lot of data and training such deep models on a very large data set which has so many classes, so that whenever people use it for their own use case, they will still have classes from that large set of classes so that their use case is still valid. So this is what the entire session was. That was on a transfer learning. Yeah, so this is from my side. The session has been completed, but now I would request that if anybody has doubts, we can clear that.
Participants, if anyone is having query, they can unmute yourself and ask the questions. So fine. Moving towards. Thank you, sir. Thank you so much for a wonderful session. And hope we don't have any questions, so we'll move further. I'm here to propose a vote of thanks. First and foremost, I would like to thank our Honorable Chairman, sir, Satish Ji Patil, sir, for supporting us to conduct such events. I would like to thank our Honorable Director, Colonel S.K. Joshi, sir, for motivating and guiding us to organize such events. I extend my heartfelt thanks to Mr. Piyush Nikam, sir, for gracing this occasion with his presence and for sharing his knowledge with us, which will definitely help us to enhance our skills. A big thanks to our beloved principal, sir, Dr. Vijay Mudai, sir, for the words of encouragement. Sir, we are honored to have you with us. My heartfelt thanks to respected Vice Principal Ma'am, Dr. P. Malati Ma'am, for her guidance and supporting all our efforts. I would like to thank our HOD, Dr. Vinayak Kotar sir, for his support and guidance he has extended to all of us. I would like to thank Mrs. Shanti Guru ma'am and Mrs. Neelam Patil ma'am, chief coordinators of the program, for their guidance and support. I extend my heartfelt thanks to organizing team members for their efforts to make these events successful. A big thanks to all dear participants for active participation and being with us. Thank you all. As we come to the closure of day 5, afternoon session 2, I would like to thanks Principal Sir, Vice Principal Ma'am, and the organizing team for such a wonderful refresher program. Thank you. Thank you, everyone.
Thank you, Piyush sir,
Thank you, ma'am.
for always extending your support.
So can you share your contact number?
Yes, there is a chat window. Somebody is asking.
Ma'am, I didn't hear it. Yeah, I can share my email ID also. You can just mail me your doubts. Yeah, I've shared my email ID. So even if you get some error, maybe you are stuck somewhere, you can actually share your logs with me if that's fine with you. So yeah, we can even discuss that too. Not an issue.
Very nice and interactive session by Piyush sir.
Thank you, ma'am.
Bhageshri ma'am, please announce tomorrow's attendance is mandatory for valedictory function.
Yes,
As chairman is going to join AICTE chairman.
yes, ma'am. Yes, ma'am. All the participants are requested to join the valedictory function without fail, and attendance for the valedictory function is mandatory. And chairman of AICT will be joining for valedictory function, so attendance will be definitely counted over there. So please consider it and attend the session. So thank you, sir. Thank you once again, and thank you all the participants for being so active and active participant. Thank you.
Thank you, everybody, for giving me a opportunity to actually interact with everybody. I liked a lot giving the session because more you teach or more you share your knowledge, even you gain that knowledge. So even I enjoyed it. Thank you.
Thank you.
Thank you, sir. Thanks a lot. There is no, what I can say, while saying each and everything, there is no ego and not, not hesitation and not showing that I know very much, very much things and I cannot share and all that. You have shared each and everything and that too down to earth. Your attitude is so much down to earth.
Thank you, ma'am.
So.
Thank you, Varsha ma'am. Could you please share the same feedback tomorrow in front of the AICT and IST dignitaries?
Yes, ma'am. Yes, definitely,
Yes.
definitely.
Yeah.
No, I'm talking from mornings, from
Yes,
point
yes.
of view
Yeah,
that
yeah, yeah.
morning.
I know, I know. No, tomorrow they will be taking feedback of the entire sessions, and you can share this on Piyush sir
Yeah, yeah,
tomorrow.
yeah,
Yeah.
yeah, yeah, yeah. Definitely,
Thank
because
you.
he is also our Indian student, right? And that person is also our Indian brain. But still, he's giving the what I can say that he's dominating us, our country, and still he's saying from taking the side from that people and all that. I don't. It's my personal view, but I don't like that.
Okay.
Adding
Other participants also, if you have to, if you want to give feedback regarding the entire slot, you can give feedback tomorrow during valedictory function. Those who are willing to give feedbacks, please post on the WhatsApp group. We will call your name and you can turn on your video and you can speak in front of the dignitaries.
Yes, ma'am.
Yes. Thank
Thank
you.
you, ma'am.
Thank you, Bhagyashree ma'am.
Yes, ma'am.
I would
Mr.
like
Piyush sir is always a good teacher, as we know him.
I would like to add, Varsha madam, Piyush is our alumni.
Yeah, ma'am. I heard yesterday's your introductory session. That's why I told na he is also our student. He is also our Indian brain, but still people are dominating us. It is not true, na.
Yes, yes.
We don't have resources. That is not our problem. Na each and every person will not get same opportunity. So whatever we have from that, from using that things, we can give our students or for developing ourselves.
Yes.
Thank you, ma'am. Thank you for your feedback.
Thanks a
Thank
lot.
you, ma'am.
Thank you, everyone. I declare the session is over. If no one want to say like anything, so can we leave, ma'am?
Yes, ma'am.
Yes, yes.
Yes.
Yes. Thank you,
Yes.
everyone. Thank you so much.
Thank you. Thank
Ma'am,
you.
I want to share one thing that
Yes,
not
ma'am. Yes, ma'am.
that
Please, please.
not like from morning session, but I have granted my patent within 7 months, and I didn't get any kind of help from my university or not from my college and not from anyone. But if you want to, if you are willing to do anything, or if you want to do anything, you can do it in our resources. So I have used the NVIDIA, I have used the GPU, I have used the deep learning things, I have used the thermal camera also. Not even any single person is using in our India that thermal cameras and working on thermal things. But I have invested my money and I have done that thing. So it is not like that we need the resources here and all that. And so many people helps me. It is not like that so many people teach me also, but so many people helps me also, and I have did that. So that is also I can say that we can also do it. It is not like that we don't have resources and we don't have all the things, so we cannot do. Whatever the best possible things we have, we can do it.
Congratulations, madam. Good.
Yes.
Yeah.
Congratulations, ma'am, for your
Congratulations, ma'am.
achievement.
Congratulations.
That's really nice that within 7 months you have filed the patent. That's
Ma'am,
really nice.
not filed, I granted the patent.
That's really
Yeah,
great.
that sounds great. Yeah.
Seriously.
Oh, thank you, ma'am. So I want to tell only that we can also do. It is not like that we cannot do,
In
and
our
we need to
resources.
go
Yes.
there and we need to do all the things by using their like we can do in some small manner, but we can.
Yes, where there is a will, there is a way.
Yes.
Yeah.
If you want to do, we can do that. Fine.
Okay. Thank you, ma'am.
Okay, ma'am. Thank you. Thank you so much.
Thank you.
Okay. Thank you.
Thank you, Piyush, once again. Thank you.
Thank you, ma'am.